I am going to be talking about remote sensing data and a little bit about the use cases of that. But to start off, I was thinking I'd actually take one of Alessandra's examples, and we could maybe do a small exercise. This is a GIF that Alessandra flashed very briefly, but it basically just shows people at different times of the day throughout where their locations, like how many people are in different areas at certain times of the day. So I was thinking maybe if we could just have a quick think about how you might want think well, like what kind of use cases you can think of for this kind of data. How might you use it for analysis? So um, there's a quick present poll. If you go to mentee.com and enter this code, you should be able to see a question with three text boxes. So you can enter up to, well, you can enter as many times as you want, but you can do three at a time. So just enter, just say what you think this data might be useful for, and then we can have a look at the results. So let's just take like a minute or two to think about this. So we're starting to get some responses. Traffic jams, interactive, location occupation, right? So we've got breadth of a city. I assume that means like a snapshot. Traffic monitoring, daily fluctuations, airport journey, right? Commuter journeys, movements during time. Yeah. So a lot about okay. So there's a lot about tracking, understanding movements, and a little bit about location occupation. Okay, energy flexibility. That's interesting. I have no clue what. Oh, it's people dynamics. Okay, commuter journeys. Yeah, daily fluctuations. Okay, so flights. I'm not okay. Events happening. Yeah, you can look at what potentially there might be some events going on. Pressure on public transportation. Yeah, that's a good one. Harbor unloading. Fine. Yeah. Um, okay, so we're still pretty much thinking along in terms of mobility, right? Uh, oh, so what I was, so there are a number of actually lots of different use cases you can look at such types of data for. So you can obviously the transportation planning and traffic management is definitely a big use case. You can look at infrastructure development, like what the road networks are like. You can look at parking solutions where you might need more parking, less parking, and that goes hand in hand with, of course, public transport as well. Urban growth and land use planning, identify areas that are being used quite frequently. You can input the analysis into zoning decisions. Maybe you want to change this, the way as particular areas are used, you might want to reconsider how your city is zoned based on that. Environmental impact assessment, you can look at like reducing emissions. This type of data can be input to emission reduction policies. You can look at green space planning decisions. And then you can also look at things like public safety and emergency response. So, certain routes, if you look at certain routes and you realize, okay, there's a lot of people congregating in a particular area at a particular time, but there are no, public safety or emergency response teams accessible, don't have access to those areas, maybe that's something to reconsider. And then disaster planning, like, yeah, what do you do in case of some disasters, like, so lots of different things to think about. Pretty much you can take this and input it into lots of different things. um, just the point of I was trying to make here is that, there's a lot of interlink in between these things. Uh, Particular data set can be used for lots of different things, input to lots of different areas of public of governance and planning. So it might be worth when you're just to when you're thinking about analyzing data, just thinking outside of what the usual or the most obvious use cases might be, and it might be worth looking at them. So remote sensing. So what is remote sensing? Remote sensing is basically the use of basically obtaining information about objects or areas from a distance using sensors that are typically either mounted on satellites or aircraft, which is why it's called remote sensing. And the benefits of remote sensing, like it's used for like large scale data collection. Obviously, if you're doing it in person or using in situ centers, can be difficult to do that at large scale. You can do it very quickly. You can do it consistently and reproducibly. It's safe for the most part. Like you're not putting people at risk in some way. You can do lots of types of analyses, multispectral analyses, which is decomposing the images into their spectrums. I was about to say spectrals, spectrums. It can be cost effective, same because it can be done at large scale with relatively a limited equipment. You can do lots of different types of cross-cutting analyses, and you can do things like environmental monitoring. And I'm just going to spend like a few minutes talking about examples of remote sensing. So these are images that these are sort of some applications we developed in a previous project. And actually, Mattia, you might recognize this because he's the one who was working on these applications. So in the project, this is an example of monitoring thermal heat loss from using satellite imagery. And what it shows is buildings and how much energy, how much heat they're emitting. And you can use this kind of imagery for example, understanding how thermal efficient buildings are, how much energy they're losing. So if you're targeting, for example, if you want to improve the insulation of buildings, then this is a good way to identify which buildings to target. With, and which buildings are the most inefficient in terms of trapping heat or remaining or insulation. Um, these are both different views of sort of the same type of data. On the right, you've again got an infrared image showing energy loss. Um, you can use this type of data. You can use remote sensing to, for example, monitor green roofs. So here we're actually looking at uh, buildings that have roof gardens or vegetation on their roofs. And this, for example, this can be used on the one hand to identify how many buildings actually have green roofs in a city, and if there is a targeted program, which was the case in this project actually, not in this project, but as part of the city. I think this was Rome that was doing this. So there was a program to have more green roofs, increase green roofs, because there was very little space otherwise to have vegetation in the city. So the problem was, how do they monitor how well the green roofs are doing, how successful the program is? So the idea was to use satellite imagery to track, um, how well the green roofs were doing. And this was, I think, actually there was AI being used to automatically detect green roofs, and sort of identify whether they're increasing or decreasing. And on the right is actually it's a prediction mechanism. It's using a simulation to predict if a green roof was installed, how much impact it might have. So the potential impact or impact of potential green roofs. On the left are actually existing green roofs and compared with potential green roofs. And then you have you can also use satellite imagery to sort of monitor flood risk and identify the risk of flood in different areas. So this is an image of Heraclian. This is again another project, Cure, which just finished last year. And the idea was to look at use satellite imagery Well, there were a number of different applications. This is an example of just one, where you could actually look at a satellite image and it would indicate which are the areas that would be most impacted in case of a flood, or have high flood hazard. And again, this can be used in planning. Again, you might want to take measures to uh, make sure that the damage in case of a flood is minimized. So yeah, that was all I wanted to keep it short and simple.